Okay, today's lesson is 6.3, Solving Systems by Elimination, and you can find this in your textbook on page 397. And it's just another technique to use. So just to review, we've done solving systems by graphing, finding the point of intersection. Then we did solving systems by substitution. And this last one, solving systems by elimination, tends to be my favorite. And let's just jump into it and see how it works. So here's the first example, and oops, that should be y. Y plus 3x equals negative 2, and 2y minus 3x equals 14. And to solve by substitution, basically you have to have the equations in standard form or at least in the same form so that the y variables line up, the x variables line up, the equal signs line up, and then the constants line up. Okay, so that's crucial. And the idea of elimination is really looking to add opposites so that one of the variables disappears. And this one is a real easy starter lesson because, as you can see, 3x and negative 3x are opposites. So we know that if you add opposites, you're going to get 0x, and in other words, the 0 will disappear. So in this case, we're going to choose the operation of addition. And we are going to add this equation to this equation. So 2y plus y is 3y. 3x plus negative 3x is 0x, which is just 0, so I don't even need to put that. And negative 2 plus 14 is 12. Divide both sides by 3 to get y equals 4. And you've got the first half of your solution. Then you do just like we've been doing. You plug y back into one of the equations and figure out what x will be. So I'm going to use this equation. If y is 4, 4 plus 3x equals negative 2. Then I'm going to solve this. I'm going to subtract 4 from both sides. So I get 3x equals negative 6. So dividing by 3, x comes out to be negative 2. And I've got my ordered pair solution that's going to make this work. This is probably the most basic idea or basic example of elimination because our x coefficients were already opposite. Okay? Now, if they aren't already opposite, but they are close to being opposite, instead of using addition, you can use subtraction. So let's write down this example. Notice again that they are in standard form, ax plus by equals c form, and we write it so that the x variables line up, the y's, and the constants. Now, as you can see, if we were to add these equations together, no variable would disappear. But notice that 3y and 3y are very close to each other, so if we subtracted both the equations, we could get one of the variables to disappear. So watch carefully. You have to do 3x minus a negative 2x. Well, remember, when you subtract a negative, that's really going to become adding a positive 2x. So 3x plus 2x is 5x. 3y minus 3y is 0y. And 15 minus negative 5. So we're subtracting a negative 5, so that's the same as adding 5. That's 20. And x comes out to be 4. So our x solution is 4. And when you substitute this back in, if x is 4, 3 times 4 is 12. 12 plus what is 15? So 12 plus 3 is 15, so y has to be 1. And we've solved that. So that's solving systems by elimination in the easiest form. That's by using addition to get one of the variables to disappear, or by using subtraction. But the next layer to solving using elimination is to first multiply one of the equations or the other equation by a constant first, so that your variables will cancel each other out. So if you take a look at this example, notice that we're not even close to being opposites. Okay? And there's a million different ways you could do this. I'm going to choose to do it this way just to model for you, but if you notice, if we multiply this entire equation by 3, what we're going to get is negative 3x plus 3y equals negative 6. And we didn't break any rules. You know that if you have an equation, if you are fair and you multiply every single term to that equation by something, you still have a balanced equation. It's an equivalent form, and it's just a different form of that equation. So if we were to graph this line without the 3, or to graph the line when everything's multiplied by 3, what you would find is the exact same line. Now the trickiest part now is you want to kind of mentally close your eyes and get rid of that. Or some students write them both over here. But now ask yourself, do we need to add or subtract to get these to cancel? And you can see that by adding 3x and negative 3x, that would become 0x. 2y plus 3y is 5y. And 6 plus negative 6 is 0. When an equation ends with just the left side having a 0, many of you just kind of, you don't finish out the equation and you just get 5y and you're not quite sure what to do. Don't be afraid to set an expression equal to 0 and then continue. Divide both sides by 5, y comes out to be 0, and you're halfway home. Okay, so then we plug this in. If y is 0, 3 times what? Plus 0 equals 6. So that's 3 times 2. And we've got our solution. Okay. All right, you should have all of these 3 examples written in your journals. And what I'd like you to do, on page 399, I would like you to do problem 3b. And if you turn the page, on page 400, I would like you to do check it out problem number 4. So I will check to see that both of these are done tomorrow, so that I'll see that you've watched the video, and then we'll continue practicing. Have a good night.